In this video, we're going to take a look at the cosine graph. Now we're going to start off with the simplest cosine graph and look at that and specific points on that. So we're going to look at y equals cosine x. We'll go ahead and make a t-chart. And I know what x values I want us to look at. I would like us to look at between 0 and 360. So let's go ahead and count in increments of 45. So we're going to start at 0, then 45, 90, 135, 180. Again, I'm just counting by 45-degree increments. So 225, 270, 315, and 360. So we're going to take those x values and we can plug them into the calculator. So we can plug each one into cosine x. So for example, cosine 0 would give you 1. So we get 1, then 0.707. And if you know your triangle trig, you actually know that that's root 2 over 2. But if not, that's okay. Then 0, and then it goes down to negative 0.707, negative 1, back to negative 0.707, back up to 0, then 0.707, and then 1. So we see a lot of repetition with these numbers, and that's because you're going to see a cycle happening here. So when we draw this graph, let's put down our coordinate plane, and I'm going to count in increments of 45. I'm actually not going to put down all the numbers, that would take too long. So 45, 90, 135, 180, 225, 270, 315, 360. Alright, so keep in mind that this is a very, very rough sketch. I don't have graph paper and I'm working on a screen here. But just to give you an idea, so that's approximately 0.707. And that's also approximately 0.707. Okay, so let's go ahead and plot these points. We start off here at 1. And then we go to 0.707, 45, and 0.707, 90, and 0. And then we keep going. We go down to 0.707, and then down even further to 1. And then negative 1, sorry. Then 225 goes with negative 0.707. 270 goes with 0. 315 with 0.707 up here. And then we end up back at 1. So our graph roughly looks like this. Kind of like a bell, but not exactly. So our cosine graph looks like this, and it's cyclical. So if I kept going in this direction, I would go again. So it goes here, and then it comes up, and then it loops back and does the same shape again, like that, over and over and over and over. All right, so that's the cosine graph. Super important that you remember the cosine graph's shape. Also super important that you remember the difference between the shape of the sine graph and the cosine graph. Since this video is not about sine, I won't go over that now, the shape of the sine graph, but very important that you're able to understand the difference between the two. All right, we're going to take this graph and we're going to do all kinds of good stuff with it. We're going to make it taller, shorter, move it up and down, left, right. Well, actually, in this video, we are not doing horizontal phase shift, but we are doing everything else. So let's go ahead and see what that all looks like. Okay, so the general equation of the sine function is y equals a cosine b x minus c plus d. But we, in this video, will not be doing any horizontal shifting. The horizontal shifting comes about with that minus c here. So for our purposes, we're going to ignore this general equation, and for our purposes, the general equation will be a cos bx plus d. So the only thing I changed here is that there will be no horizontal shifting. Some books you will find this as plus c, but I do not want you to be confused later when you are actually using the C to shift things left and right. So I'm going to call the vertical shift D. All right, so speaking of which, let's look at what each of these things is. A is the amplitude. and the amplitude is half the height. So let's just say height over 2. B is the number of cycles in 360. And we already know what one cycle looks like. It looks like this. So the number of these things here in 360. And D is the vertical shift, going up or down. So let's focus first in on the amplitude for cosine. So let's do an example. And in my example, I would like us to graph the function. Sketch y equals, let's say, 3 cosine x. All right, so in this case, our amplitude is no longer 1, which it was before. Our amplitude is now 3. But that's the only thing that's different from the graph that we drew before. So we really and truly do need to know that shape. So whenever we're asked to draw a graph, we can just draw the shape and put the numbers in after. So the shape of the cosine graph goes a little something like this. All right, and since our amplitude is 3, that means that our amplitude is 3, that means our height is twice that. Our height is 6. But we actually don't even have to think that far. With the cosine graph, it's actually pretty easy. If there is no vertical shift, the graph actually just starts at the amplitude. Again, only if there is no vertical shift, the graph starts at the amplitude. That's something that you probably want to write down. So let's go ahead and do that. The graph of cosine starts at A if there is no vertical shift. And I'm just going to say if no vert shift. All right, so again, the graph of cosine starts at the amplitude if there is no vertical shift. So our shape, again, is just the same as what we looked at in our previous slide, and it goes out to 360. All right, and the reason it goes to 360 is because in the original cosine x graph, that's where it goes to. That doesn't change unless B changes, and we'll get to that soon. All right, so let's look at an example where there is actually a vertical shift. Okay, so in this example, we're being asked to sketch the graph of y equals 3 cosine x minus 1. And we actually already know what the graph of 3 cosine x looks like because we just graphed it. But I'm going to put it back on this page. I'm going to put it in a light color since that's not what they're asking us for. So we know cosine. The cosine graph looks like this. It goes down and comes back up. It starts at the amplitude unless there's a vertical shift. Goes down to the negative amplitude again unless there's a vertical shift. So I didn't graph it with its vertical shift. I went ahead and graphed the easy part, which is 3 cosine x. No vertical shift yet. I'm going to go ahead and actually even make this dotted to make it clear that this is not what the question is asking for. But it does help us to see it. So now that we can see it, where it starts and ends if there is no vertical shift, now we can go ahead and move it down because of the negative sign, 1. And everything moves down 1. So originally it was starting at 3. That should go down to 2. So let's say this is 2, this is 1. All right, cool. So everything moves down 1. So it starts now at 2. The lowest point is now at negative 4. And it should end up on the same horizontal line, which is over here. And so the shape of the graph is the same, but everything is just moved down 1. And so that is the graph of y equals 3 cosine x minus 1. And that's how vertical shift works. So now if you were actually looking at a graph that did have a vertical shift, so let's say you were asked to identify the graph, so you weren't asked to draw it and you just saw what the end product was. And you were asked to look at, okay, what is my graph here? What is my equation here? Well, you'd recognize that it's cosine. You'd recognize that the entire height here is 6. you could do that by doing 2 minus -4, that's the entire height, is 6. Half it to figure out that the amplitude is 3. And no, okay, well, cosine should start at the amplitude. It should start at 3, but it's not starting at 3. It's starting at 2, which means that the shift must be 1. So y equals 3 because our amplitude is 3, cosine x, but because it's starting 1 lower than the amplitude, you know it was shifted down 1. All right, I hope that's clear to you. All right, so let's move on to one more thing. Let's move on to our B. Okay, so in this example, the amplitude here is 1/2, or number of cycles in 360 is 2. And there is no vertical shift. So that's good because the vertical shift is actually the hardest thing to figure out there. All right, so in sketching this graph, again, I usually just sketch the graph first and then get the numbers in after. So we know the shape of cosine, and so we can put that in. So our cosine graph looks like this. But we know that there's 2 of them in 360, so I'm going to go ahead and do another cosine curve here. And so since we know that there are 2 cosine curves within 360 according to our B value, that means this point here is 360. And halfway to that point has to be 180. And if we wanted to break up the whole thing, we could count by 90, 180, 270 here. All right, and as far as our amplitude and our top and bottom of the graph, since there is no vertical shift, the cosine curve starts at the amplitude. So that's 1/2, and that's -1/2, and that's what that graph looks like. All right, so again, there were 2 cycles in 360, and as you should know hopefully by now, one cycle looks like this, so we just drew 2 of them, and that's how we did that. All right, let's do one example. Let's make it a little funky so that we can make sure we understand everything together. Okay, so I threw in a negative amplitude here just to emphasize that the amplitude is where the cosine graph should start if there is no vertical shift. So in this case, there is a vertical shift, but I like to draw this section first and then shift it. So I'm going to draw that section in a super light color. So actually, there we go. That's what I'm going to do. I'm going to draw that section first, and then I'm going to shift it up 1. All right, so it starts at the amplitude. So in this case, it's actually starting at -2. And it's upside down. So whenever there is a negative amplitude, it's going to be upside down. So we have an upside down graph here. There are 3 cycles within 360. So I'm going to go ahead and draw those 3 cycles. 1, 2. This is great. Lots of fun. Taking it way back. All right, so 3 cycles within 360. It is really not as uniform as it should be, but that's okay. As long as you drop the right numbers in the right spot. All right, so we know that it started at the amplitude, which is -2. It's upside down because it's negative. So it goes up to 2. And we know also that there are 3 cycles in 360. So we have 1 cycle here, then another, and then it should end at 360 because, again, there are 3 cycles in 360. All right, now that's not the answer at all, so I'm going to go ahead and make this dotted, which I can't do. I can't erase it. Okay, it's not the answer. It's in a light color. We do need to move it. Where are we moving it to? We're moving it up 1 because our D, or vertical shift, is +1. So everything that is at -2 should really and truly be at -1. Everything is moved up 1. I was moving up 1 already, but you know, let's pretend that it was good. All right, and everything that was at 2 will now be at 3. So our highest point is now at 3, and it just follows that shape. So I can go ahead now and draw in that shape, and our graph looks like this. Oh, it's very bad, but it's my best effort here. All right, so that's what the graph of y equals -2 cosine 3x plus 1 looks like. And if you do have two graphs on your page, you want to label them so you know, so your readers know, so I know, whoever knows, that this is not really the answer. It was just a step you used before you shifted up, and the blue graph is in fact your answer. All right, hope that helped.